Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syahid Najmi. Today, I'm going to represent about digital modulation. My matrix number 231371763. And the digital modulation that I'm going to taking is ASK, amplitude shift keying. What's the purpose of the modulation? The purpose of ASK is to provide a straightforward way to transmit digital data using amplitude verification of a carrier signal, especially in system where simplicity and cost effectiveness are more important than robust against noise. What is needed in communication system? ASK is needed in communication system because it provides a simple way to transmit digital data over analog channel by varying the amplitude of a carrier wave, which is binary low and high. The characteristic band is bandwidth. In bandwidth, ASK depends how fast you send the bits. The faster bit need more bandwidth. For noise sensitivity, ASK is very sensitive to noise because it changes the amplitude. Any interference can make one look like a zero. For efficiency, ASK is simple and cheap, but not efficient compared to other methods. In real-world application, RFID is a good example because RFID tag use ASK to send identification data back to reader. For real-world analogies, ASK is like turning something on and off, represent digital bit. For example, light switch analogy. And in simulation, we using MATLAB, which is when binary is 1, the modulated signal is following the carrier signal, which is generated. When binary input is 0, there is no modulated signal generated. So that's all for me. Thank you.
Hi, madam. My name is Prajun. My matrix number is 231371699. Today, I will present frequency shift keying. For purpose of the modulation, FSK exists to carry digital information 0 second and 1 second by shifting the frequency of a carrier signal. Instead of changing amplitude of phase, the system simplifies between two tone, one tone for 0, another for 1. Why FSK is needed? Raw digital pulses are fragile in noisy channel. By embedding them into frequency chip, the message become more robust. Even if the signal weaken or get destroyed, the receiver can still detect which frequency is present. For bandwidth higher than ASK moderate overall, noise sensitivity, sound resilient against amplitude noise, weaker against frequency fading. Efficiency easy to implement, lower power, but not the most bandwidth efficient. Real world application ASICA and drone. ASICA and drone remote control car and drone often use FSK to send steering and stroll command. Receiver can use simple filter turn to each frequency. Real world analogy traffic light buzzer. A slow, low buzzer for wait, a fast, high buzzer for walk. Frequency change carry the instruction. This is example we use MATLAB to get the waveform. Thank you.
Tujuan utama phase shift keying ialah untuk menghantar data digital dengan mengubah fasa isyarat pembawa, bukan mengubah amplitude atau frekuensi. PSK digunakan dalam sistem yang perlu menggunakan bandwidth dan tahan terhadap bunyi bising. Penghantaran isyarat digital secara terus mudah terganggu oleh bunyi bising. PSK solve this problem by changing phase of the carrier wave mengikut isyarat digital, bukan mengubah amplitude. Untuk real-world application, PSK is commonly used in wireless communication systems such as Wi-Fi and mobile network to transmit data digital dengan lebih stabil. Amplitude dan frekuensi tidak berubah. Tinggi dan jarak gelombang sentiasa sama. Yang berubah hanyalah phase. Apabila bit 1 phase asal dan bit kosong, phase dia terbalik. Ini dipanggil phase shift 180 degree dalam BPS.
Next is a quadrature amplitude modulation QAM. Hi, my name is Nurul Ashiki Minta Rahman. So I'm going to explain about QAM. The first one is the purpose of the modulation. So QAM is a technique that acts as a combination of ASK and PSK, where its primary purpose is to achieve maximum contrast between signals and allowing several bits to be transmitted per symbol. So why QAM are needed in communication system? QAM is essential in modern communication because it addresses the core constraint faced by system developer, such as available bandwidth, permissible power, and inherent system noise. So what of the benefits of it? The first one is increased capacity, which is provides a significantly more information capacity and higher data throughput compared to basic ASK, FSK, or PSK. So the second one is a bandwidth efficiency, which is allowing higher bit rates within the same frequency range. And the last one is a modern compatibility, which is it provides compatibility with digital data services, higher data security, and a better communication quality. Next, what is the characteristic of the QAM? First one is simultaneous compatibility, where it's operated by sending two different signals simultaneously on the same carrier frequency. So the second one is linearity requirements, which it's often referred as a linear modulation techniques because it requires highly linear application to maintain signal integrity. So the third one is noise susceptibility. QAM is more susceptible to noise than simpler modulation forms because higher level memory seems offer even greater bit rates but are increasingly sensitive to interference. There's a few application that using in the real world of the QAM, which is the first one is ADSL, which stand for asymmetric digital subscriber line. Second one is wireless communication system. The third one, cellular network. And the most that we always use is Wi-Fi. The last one is a cable and satellite, which is a television or data services. So this one is a math simulation. The output, how the QAM is operated in communication system. So the left side you can see the transmitted 16 of QAM, which is you can see the dots on all the grids. So the dots present a unique code or message, and the grid is because of the dots are far apart and perfectly organized. The computer know exactly which message is which. Think of this like 16 people standing in a large room, each in their own designated square. It's very easy to tell them apart. Next one is the receive 16 QAM. So this is what the signal looks like after traveling through the air or a wire. So you can see the cloudlets. So the fuzziness is noise. So the challenge, so the receiver, so which is the receiver tu kita punya phone ataupun komputer, has to look a messy blue dot and guess which of the 16 original circle it was supposed to be. Now imagine a thick fog has filled the room. You can still see where the people are, but they are look like a blurry shape. As long as they don't walk into each other square, you can still identify them. At the end, we have the perfect signal we want to send. On the right, we see the actual signal affected by real-world interference. So as long as this blue cloud stays separated, the data arrive without error. If the cloud get too big and overlap, the data gets corrupted. So that's all from us. Thank you very much.